Assalamualaikum warahmatullahi wabarakatuh and good morning. I will divide this video lecture into three parts, starting with part 1 until part 3. This is the outline for today's lecture. So we are going to study about the index notation, rational powers, and also BODMAS. Okay, index notation, also known as exponent. So what it means by index notation? So when are we going to use it? So we are going to use the index notation where the number is repeatedly multiplied by itself. For example, you can see from these two examples given here, 4 times 4 times 4. That means 3 times 4 is repeated. And the second one is 3 over 2, which also been repeated 4 times. So we can also write in a simple way like this, where we put a bracket. 4 is the base number here with the power of 3, or you can also write for the 3 over 2 like this with the power of 4. So the red color written in this is called the index. Okay, and for the 3 over 2 with the power of 4, we can also write in this way, where we separate into 2, 3 over 2 with the power of 3 times 3 over 2 with the power of 1, where the base number here you can see is the same. Therefore, we can add the power of this 3 plus 1, which given the number of 4. Okay, last lecture we had learned about the rational numbers, and today we are going to look at to the rational powers. What is the rational powers mean? So the rational powers actually shows the numbers raised to powers of the fraction. For example, 1 over 2, 1 over 3, 1 over 4 until 1 over n. So if the number is power of these rational numbers, it will give you the square root. For example, in this case, something is a power of half, so you can see the square root of 2 like this. And if something is the power of 1 over 3, so it will written like this, cube root, and like this. And you can also write until the nth roots. And if you look at to the two example I give you here, where the result of the power of some numbers, example like this, 27 power of 1/3, it will give you the result of rational number, where you can get is equal to 3. And you can also have the result as irrational number when 27 is to the power of half, and you can also write 27 means you expand it to become 3 times 9, but square root here like this. And when you square root 3, you will get 3 power of half, but when you square root 9 here, you will get 3. So the result of 27 power of half will give you 3 power of 3 over 2. So this one is called the irrational number. You cannot get exactly the whole number. Okay, you can use this general form to solve the mathematical problem. For example, you have this a power of m times a to power of n, and you can see that both give the same base number a here. So we can solve the problem by writing like this, a to the power of m plus n. Same thing happen with the others. You can see clearly when it becomes a divided by b power of m, so it becomes a power of m times b power of negative m. Why b power of negative m? Because b is called the denominator here. Okay, same thing when you have the same base number here, a power of m divided by a power of n, so it becomes a power of m minus n. Okay, so anything that power of 0 will give you result is equal to 1. Okay, from the index rule, you can see that square root of a times b is equal to bracket here ab with the power of half, or you can separate it like this, a power of half times b power of half. Example, for this situation, you have the square root of 36 and you can expand 36 from the 4 times 9. So you can separate into two square root. So square root 4 times square root 9. So you will get 2 times 3. So it's equal to 6. But remember, there is a special case that you have to be more careful where you have the square root of a plus b. It is not mean square root a plus square root b, because this is not multiply, this is the addition. Example, you can see the difference on this. Square root of 9 plus 16 is given square root of 25, and the answer will give you 5. But if you use this situation, you can see that the square root of 9 plus 16 is not equal to, when you separate into two square root 9 plus square root 16. Square root 9, it will give you 3, and the square root of 16 will give you 4. When you add 3 plus 4 here, it will give you 7. So this will not give you the same answer. So be careful on this case. Have you ever seen this type of case? You have one straight line here and here, and then inside these two straight lines, you have the negative 4.2. So what does this mean? So this one actually shows the magnitude, and the answer is always positive, although inside these two lines it shows the negative sign. So we call that the modulus notation for negative 4.2 is equal to 4.2. So we take out the negative sign. So now give the values of 4 minus 9 and negative 3 minus 6. So the answer should be, for the first part, 4 minus 9 is 5. And the second part, negative 3 minus negative 6 actually is negative 9. But because of the modulus notation is written like this, so the answer is not negative 9, but you have to answer as 9. So this is the magnitude. Okay, next we are going to look at to BODMAS, BODMAS. So what does BODMAS stand for? So B is the brackets, means it shows the highest priority during calculation. O is the of, multiplication by a fraction. D, division. M, multiplication. A, addition, and the last one, S, is the subtraction, which shows the lowest priority during calculation. So this is the important rules that you have to follow when you want to solve any problem in mathematics. Okay, so actually BODMAS will help you to do the correct order for performing a calculation. So it will involve more than one operator. That means it has the addition, multiplication, division, and so forth. Okay, so the answer will be correct if perform the operation in the right order. So you have to know what does it means by BODMAS. Okay, let's start with these two examples. Okay, I give you 1 minute to solve the problem. Okay, if you look at to the first part here, you can see half times bracket 5 minus 2 plus 3 minus 12 divided by 4 plus 3 times 2 power of 2. So how we can solve this problem? So to get a correct answer, you have to follow the BODMAS rule. Okay, so if we have the bracket, it's more easier. Okay, first you have to settle the bracket B. Okay, so 5 minus 2 is equal to 3. Then BOD. D will be divide, so you have to settle this part. So 12 divided by 4 is equal to 3. Then you have this one, multiplication. So 2 power of 2 is 4. So 4 times 3 is 12. Okay, so maybe it's become easier if we can write the bracket like this, where we know which one we have to settle first. Okay, so in this case, the first part, 3 times half will become 3 over 2 plus 3, and then minus, because we have settled this one, 12 divided by 4 will give you 3, plus 3 times 4 will give you 12. So the answer for this is 27 divided by 2. Okay, same thing for the second part. By using the BODMAS also, it's easier if you can make a bracket like this. Okay, you know which one you will settle first. Okay, in this case, we have to settle the bracket. Okay, 3 times 10 to power of 2, and then this one all power of 2. So inside here actually shows 300 times 300, and then 3200 divided by 4 will give you 800, and this one in the bracket here, 6 times 120 will give you 720. Then after you settle off this one, then you will get the correct answer, 3680. Okay, same thing happened for this question. Okay, you have 2.5 times 10 to power of 2. So make sure you make a bracket like this. And then you have another multiplication, 0.5 times 10 to power of 2. Then power of 2. Divide by, okay, divide by 4 times 10 to power of 4. So if we have make the bracket, it's easier to solve the problem. So it become like this. When you multiply this one, it become 250 minus this one will give you 50, and all of this actually shows the power of 2. So you can get this one, power of 2, divide by 4 times 10 to power of 4, so it become 40,000. Okay, so the answer for this part will give you is equal to 1. Okay, how about the last one? Okay, so in this case also we can make a bracket like this. It's easier. Okay, and then be careful, this one is 1 over 2 times 4 with the power of 1 over 3. That means this one shows the cube root. Okay, so you can solve this problem by multiply first 2 times 4 and become 8. So this one is the cube root. Okay, and then minus this one also, you can solve the problem first, so it will give you 1 over 4. So answer in this case is 1 over 4. Okay. Okay, try these examples. So in this question, you are asking to show how you can solve this problem. If you can see here, S is equal to UT plus half AT power of 2. So in what order should the calculation be performed if we want to calculate a value of S? So the easier way, remember the word BODMAS. So first you have to calculate the T power of 2 first, and then you multiply ut, and also the second part half times this one. The last part only you add ut plus half at power of 2. Then you will get the correct answer for this S. Okay, let's look to this exercise. The heat capacity with the symbol Cp of a substance can be calculated as shown below. Okay, this is the formula how to get the Cp. And the T is the thermodynamic temperature. And the factors relate to values of Cp is expressed in units. Given here, joule per Kelvin per mole. So now you are asking to find what is the value of Cp at 127 degrees Celsius. Remember, in chemistry, we always use the Kelvin to solve any problems that related to the temperature. Okay, at the beginning, you have to change the degree Celsius to Kelvin. Okay, and then by using the formula given here, you just replace the T with this value 400. Okay, and then when you want to solve the problem, remember the rule BODMAS, and the last answer you should get 121.31 joule per Kelvin per mole. Remember, the answer for the last part must be shown with the unit. Without the unit, you will not get any mark, although your answer is correct. Remember this. That's all, and see you in the part 2. Thank you.